Example 5. Assume that your child was just born. You decide to start a college fund for your child. You plan to deposit money annually for the next 18 years. The first deposit of $4,000 will be made next year, and the amount will grow at 5% per year. What is the value of a college fund today? Assume a rate of return of 6% per year. Okay. So we have another multiple cash flow problem, and the first step is to recognize what type of cash flow you're dealing with. Okay. Here we have a regularly occurring cash flows. You're making a deposit every single year for a finite period of time. You're only going to do it for 18 years. Okay. And the deposit amount grows at a constant rate at 5% per year. So this is a growing annuity problem. Okay. So we're going to draw the timeline. Time 0 is right now. 1, 2, 3. We'll do 17 and 18. So it says the first deposit of 4,000 will be made in year 1, and the amount will grow at 5% per year. So in the second year, it will be just 4,000 times 1.05. In the third year, it will be 4,000 times 1.05 squared. And the pattern continues until year 18. So the last payment or last deposit will be raised to the 17th power. So you won't actually need these numbers when you do the calculation, but I hope you understand what it looks like. Okay. So we're given the R. The rate of return is 6%. So this is the discount rate. And the ultimate goal here is to figure out the present value of the college fund. What's the value of the college fund today? Okay. So I'll indicate it like this. So as always, it's important to first recognize what type of cash flow we're working with. Here we have a growing annuity. Okay. So again, regularly occurring cash flows. So every single year you have these cash flows. And it goes on for a finite period of time. It ends. And it grows at a constant rate. In this case, the growth rate of the cash flow is 5%. Okay, so we have a growing annuity. Since we're trying to solve for the present value of this series of deposits, we're going to use the PVGA formula, present value of a growing annuity. Okay. It still has this t plus 1 relationship. I'll just first write down the formula. 1 plus g, 1 plus r to the nth power. That's the formula. Okay. So as with all the other formulas, present value of annuity and present value of a perpetuity and a present value of a growing perpetuity, we still have these time indicators, t and t plus 1. And how we apply the formula is still the same. We're going to check when the first cash flow occurs in that cash flow pattern. So in this case, it occurs in year 1. Okay, so it's the base case, and that makes the problem easier. This means whatever value that you get from this formula, that value will be in time $0, just one period prior to the first cash flow. Okay, so this one's PVGA time 0 is the first cash flow, which is $4,000 over R minus G. R is 6%, G is 5%, and then we plug the numbers in. 1 plus G is 1.05, 1 plus R, 1.06. This entire thing raised to the 18th power. Okay, so here's another important point. It's 18 because we have an 18-year growing annuity. Okay, so this is an annuity whose contract was signed at time 0 and it goes on for 18 years. Okay, so if you plug the numbers in, you get $62,742.36.